All right, x cannot equal 0. That's your excluded function. Asymptotes. How do I write the, cross out holes? We're not doing holes just yet. How do I write the asymptotes? What's the equation of the x-axis? Okay, make sure you write it as an equation because it's a line. So we've got y equals 0 for the x-axis, and what is it for the y-axis? All right, so we all got that down. Domain. Careful with your domain. What do you got for the domain, Owen?
Regular parentheses, negative infinity, comma 0, close, regular parentheses, and then regular parentheses, 0, positive infinity.
Okay.
Wouldn't the parentheses next to the 0 be square plus 0?
Is 0 included in the domain?
Yeah, but I thought you said anything that isn't infinity would have.
Oh, no. Remember we talked, I know we haven't done domain and range in a while, but the square bracket means it's included, and the parentheses means it's not included. Is 0 included in the domain if it's an excluded value? No. Okay, so we should have parentheses for both of those. And the range, what's the range going to be? Same thing, right? Because it's everything except for that asymptote. All right, so there's your domain and range. Again, this is for the parent function. We're going to get fancy in a little bit. All right, intervals of increase and decrease. This old favorite. This is where most people had trouble earlier in this year. So let's see how we do. If I was walking on my graph from the left side, and I'm walking along my graph, am I going up or down? Okay, so that's an interval of decrease. I start at negative infinity all the way on the left, and I'm going to be decreasing until I get where?
0.
To my asymptote at 0. Then I'm going to hop over that fence there, and I'm going to get back on my graph, and am I increasing or decreasing? Decreasing again from 0 to positive infinity, right? Now, I'll remind you, the intervals in increase and decrease always have to equal your domain, right? Well, if our whole domain is decreasing, then in our interval of increase, we have no solution, or the null set. There isn't anywhere on that graph where I'm going to be going uphill. That's my type of walking. Everything's downhill. Okay, x-intercepts. Where does our parent function touch the x-axis? Never. Where does our parent function touch the y-axis? Never. Only if there is an interval when it increases or decreases. Right? It never increases, so there's no max and no min.
Wouldn't there not be, I thought you needed that to have an interval in there also being
No. If you were walking along the green line,
yeah, I know. I thought that we had to have
you have to have an answer for it, but in this case, the increase, the answer is no solution. And the decrease is these two intervals. All right, and behavior. As x approaches positive infinity, y approaches 0. As x approaches negative infinity, y approaches 0. Listen to me carefully. Your end behaviors are always going to approach your horizontal asymptote. Always going to approach your horizontal asymptote. Those are your end behaviors. Don't quote me wrong later, because I'll get you on it. End behaviors always approach your horizontal asymptote. Okay, down at the bottom, I'm going to give you 2 more minutes if you just jumped in here. Put these in the calculator, sketch the graphs. Let's see what you get. And put them in the calculator correctly. Some of you are saying, oh, what does she mean by that? Correctly. I want them correctly in the calculator. And if you want to take it a step further, think about the transformations that we did in units 1, 2, and 3. And see if what you're getting in here correctly does the transformation. Just to check yourself. I would say we got more than 50% of you on the right page. For number 1 here, the number next to the X should be what transformation? Right or left? Look at your paper. Some of you went up because you didn't put in your calculator correctly. When you put in the calculator, you have to put the whole denominator in parentheses. Otherwise, your calculator is doing this. Okay? So make sure you put it in the calculator correctly. There is also, if you want to get fancy, and I was called out on this in 4th period, which is fine, I find that sometimes the new enhancements to the calculator make my life more difficult because I'm old and I've been using the old calculators for a long time. If you want to learn the calculator buttons, that's fine. You could type this in. Let me get rid of this. And this is for everybody if you want to know it. If you do, watch, if you do alpha y equals, it says numerator, denominator. And then you can fill in your 1 on top, go down to the bottom, and you can fill in your x plus 2, is it? X plus 2? Okay, and you can do it that way if you want. I think that's more keystrokes than I need to push. I'd rather just use the parentheses. So it's entirely up to you. Know that that's there, and if you want to learn it that way, that's fine. Or make sure that when you put it in, you do it as 1 divided by parentheses x plus 2. Make sure you put your whole denominator in parentheses. Okay? Either way is fine. I'm not trying to hide calculator strokes from you guys if you want to learn them. I just think that that was a whole lot more work than parentheses. All right, so back here we go. All right, so the first one here, what is our shift that we should have seen? Left 2. So instead of being here and here, I should go left 1, 2 over here and left 1, 2 over here. I also have to shift my asymptotes. Okay, so instead of being the y-axis, if I shift left, there's my asymptote at -2. My horizontal asymptote doesn't change. And now, oh, I kind of missed. And now I have my graph that looks like that. Sometimes it's hard to be accurate up here. Hopefully yours looks better than mine does. Okay? What should be our shift here? Over the what? Over the x-axis. So if we started with this point here and this point here, well, that point's going to reflect up here, that point's going to reflect down here. Are any of my asymptotes going to change? No, so I would keep my asymptotes at my y-axis and my x-axis. Let me see if I can do a better job drawing this one. And we hit our point and come down, and we hit our point and go over. So there's the reflection over the x-axis. Oh, I did that wrong. I hit the wrong points. That was terrible. That was terrible.
My reflection show.
We're down here and we're up here. Okay, so we're like this. Sorry. We're like that, right? Okay, next one. What's our transformations?
Up 3.
Up 3. So instead of 1, 1, if I started here, 1, 2, 3 is going to be up here. Start down here, 1, 2, 3 is here. I have to shift my horizontal asymptote. So instead of being the x-axis, my horizontal asymptote is going to be up here. My vertical asymptote is going to stay. And I'm going to have something that looks like that. Last one. Now, if you didn't have a calculator, we are not going to freak out. What's our transformation? This one?
Vertical stretch.
Vertical stretch of 2.
That's a
Okay, and I know that in the past, sometimes we had trouble finding points when we had a vertical stretch, but let's not panic. What can I plug in for x to get myself a good point?
1.
1. If I plug 1 in, what am I going to get for y?
2.
Oh, look at that. Is there something else easy I can plug in there?
2.
2. If I plug 2 in, what am I going to get?
1.
Oh. And you notice how these are all reflective, right? You can say that it reflects, if I put, it reflects over negative, y equals negative x, or 180-degree rotation over the origin, whatever you want to think. So if I have these 2 points, can I put them down here also? Isn't it going to be here and here? Yes? Is my asymptote going to change? No. So I can put my asymptotes in. I can put my asymptotes in. And I can draw my graph. They're not going to be the prettiest graphs. But again, I should see those points. I should see the asymptotes in the right place. Okay? So yes, transformations are coming back in a big way here. All right?
Just like the shape.
Now, we're going to, yes, question?
How many points do you want us to find?
I should see at least these 2 points and the 2 asymptotes. After that, anything else is kind of gravy. Yes.
But if we multiply the x parameters of the y value in those 2 points by 2, we get
I'll give you it. Put that in your calculator. Let's look at the table. 2 divided by x. Good thing to check.
Wait, what?
Right? The function is 2 divided by x. So let's look for those points and see if we got it right.
What point then?
Second graph.
We said if x is 1, y is 2. Does that fit with the table?
Yeah, like,
And how about 2 comma 1? Does that fit with the table?
Yeah.
yeah, but that's not the opposite side though.
Okay, so how about -1, -2? Does that fit with the table? And -2, -1? Okay, so we are right there.
Wait, where would the asymptotes go again?
The asymptotes don't change. It's the x and the y axis. Because a vertical stretch or compression isn't going to change your asymptotes. Okay? Okay. We're going to jump a little bit here. No, maybe not. Maybe we will do this one. Yeah, we're going to do this next. We're going to talk about asymptotes. Next page. All right. You're given a graph. Now, Here's the difference. This is Algebra 2. This is Honors Algebra 2 and Pre-Calculus. Now, don't panic, we are not doing Pre-Calculus this year, but I'm just telling you, all of this is going to come back to haunt you a year from right now. Second semester of Pre-Calculus is like Algebra 3, sort of, kind of. So all of this stuff, plus some, is going to come back to haunt you 1 year from now. Promise you. Huh? No.
How?
Not here, it's not. Some places it is, not here.
It's just like recount.
Right here.
They're nuts.
Right here. More. There is so much more that we can do with this. So much more. Okay, let's not get off track because I do want to get through a good chunk of this before we run out of time. All right, asymptotes. Well, I can look at that graph and I can draw in my asymptotes, right? I can look at it and I can say, well, I got a vertical asymptote there and I have a horizontal asymptote there. And what's the equation of my vertical asymptote? X equals -2. And what's the equation of my horizontal asymptote? Y equals 2. Okay, that's no big deal, right? Now, let's look at the other one here. Well, I can see a vertical asymptote here.
Which line is which?
I can see a vertical asymptote here. I can see a vertical asymptote here. Now, horizontal asymptote, well, I'm looking at my ends here and I'm thinking, well, that's a horizontal asymptote, but in the middle here, you see how you cross it? That's allowed. What? That's allowed. We can cross a horizontal asymptote, except at the ends. Remember what I said earlier? I said your end behaviors are always your horizontal asymptote. Look at that. Here's our end behavior. Here's our end behavior. Your end behaviors are always your horizontal asymptote. However, you can cross it in the middle. You can cross it in the middle. Relax. As I said, some of this is pre-calculus. As long as you know, don't freak out just because the middle of your graph crosses your horizontal asymptote. That's okay. All right? Now, what are our vertical asymptotes? Let's get them written down. What do we think?
-1.
-1, okay, x equal, and don't write x equals -1 comma, blah, blah, blah. No, these are lines, so I want a separate equation for each one. So what's our next one? X equals 2, like that, and we got one more, don't we? X equals 5, sounds good. Okay, and our horizontal asymptote, y equals -2. That wasn't so bad. That wasn't so bad. All the moaning and groaning, yes.
So what do you mean when you say like the end behavior stuff? You're talking about the asymptote?
Your end behaviors always approach your horizontal asymptote. It's okay to cross it in the middle here, but if unfortunately with the smartboard it's hard to do. If I were to cover up all of this, pretend you can't see any of that, horizontal asymptote with the end behaviors approaching it. Okay? Whatever goes in here, doesn't matter. Okay? Now, what does matter, see, if you are in pre-calculus next year, you would be defining that, you would be writing this function. Okay, you would be writing this function. There'd be a whole lot involved here. We're not doing that. We're just doing asymptotes.
Amen.
Okay, that's why I said, don't panic. We're good. All right. I want to jump to. No. Keep going. Keep going. Keep going. All right, this page, 5, 6, 7, 8. 5, 6, 7, 8. on that page, okay? We all there? Okay. Because we're going right to the top, guys. We're going to do all of this at once. Now, number 8. Could you please factor the numerator and factor the denominator? Start there.
Yes.
Factor the numerator, factor the denominator. All this lovely factoring. Eddie, you got one for me? What you got?
X plus 2, 3x minus 2, 2x.
Oh, no, I'm sorry. X plus 2 and 3x minus 2
Yeah.
for the top. All right, I like that. Go ahead.
2x plus 5, 2x plus 1.
Can't be 2x plus 1.
2x plus 5.
I'm kind of wondering about this 5. Because I only have a 2 here, so I'm thinking we're going to try that one again.
Oh, my bad.
What'd you get for the bottom?
X plus 2, 2x plus 1.
X plus 2 and 2x plus 1. I like that. You were getting too big, I think.
No, I misheard the 2 is 4.
Oh, okay. Okay, are we good? This is what you're going to do. And I don't know, you may want to put this on another piece of paper because we're going to be writing all over the place. That's why I did this. Okay, the first thing you're going to do, even though if you look at here, see it has vertical asymptote, horizontal asymptote holes? You don't want to do it. The first thing you want to do is find your holes. Okay, so I'm going to put a number 1 right here. I missed that. First thing you want to do is deal with your holes. Deal with your holes. Okay? Holes. Yes, some of these graphs have holes. Now, if you have a numerator and a denominator that are the same, we just spent 2 days simplifying fractions, adding, subtracting fractions, right? Solving fractions. So if I were to simplify this, these would cancel out, and I would have 3x minus 2 over 2x plus 1, right? We all agree mathematically we could cancel that out, right? Well, look at this lovely pre-calculus poster we have here. Right down here, do you see how there's a hole in that graph? See that hole right there? Right there, see that hole? That is called removable discontinuity. Okay? Now, we are not testing vocabulary in Algebra 2. In pre-calculus, yes. We just removed this, didn't we? We canceled it out. And we got this. That is a hole right there. We just had a hole. Okay? What I want you to do correctly is you're all sitting next to somebody or there's somebody behind you, whatever. I want the person on the left to type into their calculator this function. I want the person on the right to type into their calculator the small function. Okay? don't forget your parentheses.
So it's not so extra.
What do we have on the bottom?
Yeah.
Minus 2. And 2x plus 1?
The 3x minus 2 didn't show up.
Oh, I hate this thing. And then what is it? 2x plus 1. Okay. Do you each have it in? Okay. Press graph and compare your graph with your neighbor's graph.
Whoa, I think they're the same.
Press graph. Did you get the same graph? You got the same graph, didn't you? Then you need to work on how you put in the calculator, check your parentheses. I put both of them in and only got one graph, right? They're both the same graph. The only difference is that one of them has a hole, which you can't see, and the other one doesn't. Now, go to your table. Go to your table. Look at this mess. Look at your table.
My table's broken.
Do you see how where am I here? I have error at -2 for one of them, but not at the other. This is my hole, and I removed it to get a full graph. Oh. Now, if you look somewhere, you both have an error. Where's that? Up here? Down below? Well, it must be the other way. Oh, it may not be in our table because it's not a whole number. It's not in our table, it's not homework. Okay? But that's removable discontinuity. If we cancel out like factors, we remove the hole and then we have the same graph, we just don't have a hole in it. Okay? So, back to where we were. Alright, so, this is what you're going to do. You're going to identify your hole. So, you have a hole. Now, if I say x plus 2 equals 0, x equals -2, the x coordinate of my hole is at -2. Okay? But a hole is a point. That's why we make it an open circle. The hole is a point. So, if I plug this -2 in, now don't panic, you don't have to plug it into the complicated one. You're going to plug it into the simplified one, right? So, y equals 3 times -2 minus 2 and 2 times -2 plus 1. What do we get? What do we get? 8 over 3? Yep, because I get -8 over -3, 8 over 3. So my hole is at -2, positive 8 over 3. Are you with me? If we go back to the beginning of this unit, we said you would factor and you would say -2 is an exclusion, right? And you would say that -1/2 is an exclusion, yes? Okay, your exclusions are either holes or vertical asymptotes. -2 is a hole, that's why it's an exclusion. Alright, if I go back to my graph, technically, at -2, I should have a big fat, I can't do it. I should have a big fat hole there on my graph. Okay? But I don't because my calculator won't show it. So I have a hole at -2, 8/3. The next thing you're going to do is your vertical asymptote. So, vertical asymptote. Our vertical asymptote is the rest of our denominator. In this case, the rest of our denominator is 2x plus 1, so 2x equals -1 and x equals -1/2. That's my vertical asymptote. Okay? So I found my hole first, and then I deal with whatever's left over for a vertical asymptote. Yes?
Why do you take the 2x plus 1? 2x minus 2.
Because remember, it's the excluded values. What's going to make my fraction equal 0? And that all comes from the denominator.
Wait, because that's what makes your, value equal 0.
I should have said undefined. My fault. Thank you. Yeah, it's whatever's going to make my fraction be undefined. So whatever makes my denominator equal 0 is my excluded values. Okay.
I thought that was the,
Do you need more pass or no?
I thought that was the excluded values though.
The excluded values are either holes, x coordinates of the hole, or vertical asymptotes.
Okay, so what do we write there?
I'll get to all that later. I'm not doing that right now. Okay, now, horizontal asymptote, here's where you're going to have to, there is no way around it. You're going to have to go home and memorize this.
No. Don't worry. What? Wait, so our excluded values also hold the vertical asymptote?
You're excluded, yes, because -2 is an excluded value, and that's a hole, and -1/2 is an asymptote, and that's an excluded value.
And it's okay.
Okay, horizontal asymptotes. Horizontal asymptotes. I'm running out of room. Okay. You're going to compare degrees. And this is all on that page of notes, but I just wanted to talk through it. You're going to compare the degree of the numerator and the degree of the denominator. So you have three choices. The degrees are the same, the numerator's bigger, the denominator's bigger, right? Those are your only choices. In this case, our degrees are equal, right? Think of it this way. There's a tie. They're equal. Degree of 2, degree of 2. How do we break a tie? Okay? If the degrees are equal, you break the tie by the leading coefficients. So we would have, if it's a horizontal asymptote, is it y equals or x equals? Oh, you're right the first time. It's y equals, and we're going to look right here. Y equals 3/2. There's your horizontal asymptote. If the degrees are equal, you have to break the tie, and you do that by using your leading coefficients. Yes.
If they're not equal,
We'll get there. I promise we will get there. Just hold that thought. Yes.
On our, when we take the test for this, are we gonna have a sheet?
No. No. That's what I said. You need to go home and memorize this. You need to go home and memorize. Okay. Now, let's look at what we have. Let's fill in here. We're looking at number 8. Our excluded values, we said, was x equals -2 and -1/2, right? Those are our excluded values. Equals, not equals, I'm not really quite sure which way to do this. I'll take either one. We said our vertical asymptote was x equals -1/2, right? We said our horizontal asymptote was y equals 3/2. We said we had a hole at -2 and 8/3.
Yeah.
Okay. Now, once we have all of that first, now we can deal with our domain and range. Because we have to consider all of our exclusions. So our domain, we know we're going to start at -infinity. Where's the first issue? Is it at -2 or -1/2? -2. So -infinity to -2. And it doesn't matter if it's a hole or an asymptote, it's still going to be something that we have to jump over, right? And then we're going to go from -2 to -1/2, and then we're going to go from -1/2 to +infinity. So that's why you gotta set all of this up before you start doing any domain and range and stuff. Yes,
But it excluded values, it's only X values.
yes, yes. Can't hurt that. Okay, now think about your range. We know we're gonna start at negative infinity. And where's the first place we get stuck? 3/2. That's our horizontal asymptote. And then we're going to go 3/2 to where? We can clear to go all the way up? We got a hole to jump over. So 8/3, and then we've got 8/3 to positive infinity. Okay. Now, x-intercepts. X-intercepts. What do we know about every point on the x-axis? Y value 0. Okay, I'm going to get rid of all of this so I have a little bit of room here. The y value is 0. So if I take, I already did my factoring, I don't need it again. So if I take my y and make it 0, x plus 2, 3x minus 2, x plus 2, 2x plus 1. Who can shorten that up for us?
Wait, I thought we keep the whole term.
Well, that's what I'm asking. Can we shorten that up? What do you want to get rid of? Okay, the x plus 2 is going to cancel. Okay, so I've got 0 equals 3x minus 2 and 2x plus 1. Then what happens?
Multiply by 2x plus 1 minus.
If I multiply both sides by 2x plus 1, the denominator, isn't that just going to mean that the numerator is going to equal 0?
Sure.
So keep that in mind for future reference. If you're looking for your x-intercepts, all you have to do is set your numerator equal to 0. Right? Because when you multiply by the denominator, it's going to be times 0. So for our x-intercepts, we're going to set our numerator, our simplified numerator, equal to 0, right? So 2 equals 3x, and x equals 2/3. There's our x-intercept. Right? So our x-intercept is going to be 2/3, 0. Make sure you write it as a point. Don't give me x equals. I want a point. An intercept is a point. Now, what do we know about a y-intercept? X is 0. Well, that's easy enough. Think about it. If x is 0, doesn't this cancel? Doesn't this cancel? Doesn't this cancel? Doesn't this cancel, right? If x is 0, aren't all of those going to be 0? Yeah. So my y-intercept is just going to be -4/2, which is -2. So 0, -2 is my y-intercept. No guessing. No looking at your graph and say, oh, I think it's about... No, you're going to actually solve for it.
Can you do the same thing that you do with the x-intercept and just use like the easy equation?
Yes. 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 But honestly, I think just crossing out everything that has an x is easier than putting it in here, but that's just me.
Ow.
All right, so let's see, where are we here? So we have our x-intercept was 2/3. Thank you. And our y-intercept was 0, -2. Now, our end behavior, we don't have a graph to look at. What's our end behavior is going to be?
The
A horizontal asymptote, which we know is 3/2. So I'm just going to put in 3/2 and 3/2. We're good to go.
Whoa.
Whoa. Whoa. Whoa. Okay, I know that was kind of a leap, But I just wanted you to have the big picture, and now we're gonna back it up a little bit. Oh, yeah, come on. Back it up a little bit. All right. Let's look at this one. Let's look at this one.
Okay.
What are our excluded values? Number one. What's our excluded values? 4, right? X is not equal to 4. Okay. Now, since you're given a graph, let's just do the asymptotes right on the graph, huh? What do we got for an asymptote? I think we're looking. I crossed over 5, so I'm going with 4. Right? And I'm going for 0. Okay. Now, vertical asymptote is x equals 4. Now, we looked at the graph, and we said the horizontal asymptote is y equals 0, right? Okay, this is the second case. Remember I said the first thing you do is you compare your degrees. Well, the degree up here, wouldn't this be x to the 0 power? So in this case, your denominator is bigger because that's a first power, right? So if the degree of the denominator is larger, your horizontal asymptote is always y equals 0. Always. If the denominator has the bigger degree. Okay? Down here, what do you know about the degrees? They're equal. So how do we break the tie? Coefficient. So here, your horizontal one is going to be y equals 3. All right?
What happens if the numerator is
If the numerator is bigger, there is no horizontal asymptote.
Oh.
There's actually an oblique asymptote, and we don't do that in Algebra 2. You can have that one next year. Okay, so let's go back up here and see if we can finish this up. Okay. Are there any holes? Are there any holes?
No.
No? You don't have the same factors, numerator, denominator? No holes. What's our domain going to be?
Don't they both have 1
Negative 4.
as a
Negative
factor?
infinity to 4?
Wait, this one.
I'm hearing? Yes? No?
I have 4 to positive.
Don't they both have
And
1?
then 4, hold on, to positive infinity. Hold on. The one domain, and I don't know where your question is. What's your question?
Don't they both have 1 as a factor? Or does that like not matter?
By linear factor.
Oh, okay.
Linear factor. Yes. You have the point, but everybody has 1. So that doesn't get us. You're right, but that doesn't help much. Okay, what's our rate? Oh, speaking of it. I'm so sorry.
Yeah.
What?
Wait, what if we
Somebody asked for
put it
Janet like a while ago, and
That's me.
I'm so sorry.
it has to be like
Wait, speaking of being helpful, I'm not. All right, what's the range going to be?
yeah, it has to be closer now.
Okay, that one wasn't so bad. X-intercepts. None. Y-intercept. Yeah, remember you put a 0 in for X, so it would be 0 and 9/4. And how about our end? Negative 9/4, thank you. And how about our end behaviors? 0, 0. Not so bad, right? Okay, listen to me. We still have, hold on, we still have a few minutes. Listen to me. Thanks, appreciate that. Keeping me straight. Listen to me. On your homework, now your homework, there's some pages in the book, there's some, this is what I want you to do for your homework. This page here where we did number 8, I want you to have all the problems up to number 8 completed, which means you do not have to do the last 3 pages of the packet, the notes, And you do not have to do the textbook work. I just want you to do up through problem number 8 for homework tonight.
One day.
But everything up through number 8, whatever that is.
Oh wait, don't do the.
Don't cross it off, because we're going to get to it, just don't have to do it for homework. For homework tonight, all you have to do is up through this page right here.
Cool.
Now, listen to me.
Wait.
Stop moving around, stop fussing with your papers, just sit there and listen. Class is not over. I'm going to turn this off so I can yell at you. You think I'm kidding? I'm not.